Okay, let's deal with position converting from one frame to the other frame. So when we have two coordinate system, O naught, X naught, and Y naught, which is the solid line over here, and we have another frame tilted, which is O1, X1, and Y1. So if we try to find out the point or the position described in X1, Y1, and X0, Y0, how are we going to convert from one coordinate into another coordinate? That is something we're going to do. But before we start, let's talk about the concept over here. So we got P. Those two P means the same position. We can do it over here. Let's say this is P. Okay, so when we are dealing with this specific P, we can describe that into two coordinates, of course. And if we use the dashed line over here, we say we observe everything from zero frame. And if you are using this coordinate over here, we say we describe everything from the first frame. They are the same position. However, the numbers are not going to be the same. So how are we going to convert between those two? So we need to know the R1, 0. This is the first frame described from, this is the reference observed from zero frame. So if we try to convert this one to zero frame, then we need to use this one to do the conversion or transforming. What I mean is that because we try to describe this position using zero frame, so the conversion is from 0 to 1. If we can multiply this matrix together with this vector, we can get the information of P naught based on this calculation. Similarly, if we want to do P1 based on the information of P naught, what we need to do is we are finding out how my zero frame observed from the first frame. Okay, so this is something that we're going to use to convert from one coordinate to another coordinate. Those two, you might say, okay, I know there must be some relationship, but I can find out the relationship based on the technique we derived from the previous slide. But how am I going to use this one? Well, this one over here is going to be the inverse of this one. And we know inverse transformation of matrix is somewhat a little bit tedious. But since we are dealing with unit vector, this is just a transformation of the system over here, which means if you try to do something like this, P1 is actually R1, 0, T, P naught. So if we know how to deal with the transformation over here, we can actually come up with position from one frame to the other frame. Let's deal with one of the example. So, okay, give two coordinate frames. If the second frame is rotated for 30 degrees, calculate the position in the second frame of 3, 6 measured in frame 1. Okay, so let's start. Let's say this one is X1, Y1. And the second frame is going to be tilted for 30 degrees. Let's name this X2. And this is Y2. Okay, So clearly, the transformation matrix, if I want to find out the second frame viewed from the first frame, this matrix is straightforward. We are going to have cosine 30 degree. The y is going to be sine 30 degree. Again, we are using the unit vector. So we are dealing with cosine and sine. On the other side, we're going to have negative sine 30 degree and cosine 30 degree over here. So this is going to be my transformation matrix. And this one over here is going to be 0.866, 0.5, negative 0.5, and this one is going to be 0.866. Pretty straightforward. Now, we want to find out the position or the coordinate of the point measured in second frame using the information we measured from the first frame. So when we are doing something like this, what we need to do is we need to describe 2 from the second frame of the first frame. So this is something we're talking about over here. But again, the one we derive over here is not this one. However, you might notice this one is the inverse of this one. So what we can do is just do 2, 1. And based on the formula we have in a previous slide, it's going to be just a transpose. And we do P1, which means the transpose of this matrix is going to be 0.866, negative 0.5, 0.5, 0.866. And we are dealing with 3 and 6. So the answer for this one is going to be 5.598, 3.696. Okay, what does that mean in the two-dimensional representation? Let me change the color again. So I say I want to do 3 and 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. So this one is P1. 3, 6. But let me change the color again so it might be easier to visualize what's going on over here. Let's use this color. So if you project this one onto the x2 and y2 coordinate, this one over here is going to be 5.598. This one over here is going to be 3.696. So this is also equals to P2 equals to 5.598, 3.696. So they are meaning the same thing, but measured from different coordinates. Okay, let's stop here, and we're going to talk about three-dimensional transformation later.